Welcome back to our heat transfer class, where we are delving into the phenomenon of the exchange of thermal energy between surfaces by radiation. This video was made with the support of InnoEnergy. After studying the behavior of real surfaces, in this lesson we will study the view factors between surfaces. We will divide this lesson into several parts. The objective is to analyze the radiant energy that comes out of a surface and falls directly on another surface. The view factor definition. The view factor of 1 to 2 is defined as the fraction of the radiation leaving surface 1 that directly reaches surface 2. From the definition of radiation intensity of a blackbody, we can calculate the radiant energy leaving differential surface 1 and directly incident on differential surface 2. This is equal to the product of the radiation intensity by the area 1 projected in the direction of the receiver and by the solid angle subtended by the receiver when seen from the emitter. With the definition of the solid angle subtended by surface 2 seen from surface 1. And, substituting in the first equation, we have the expression of the radiation that leaves the surface 1 and directly reaches the surface 2 as a function of the surface's dimensions, the angles, and the distance. To calculate the fraction that this radiation from 1 to 2 represents with respect to the total radiation emitted by 1, we must calculate the radiation that leaves the surface 1 towards the entire universe. For a black surface, this is the emissive power of surface 1 multiplied by the area. As we deduced in the lesson of radiation intensity, the emissive power of a blackbody is pi multiplied by the radiation intensity. Substituting both expressions for the emissive power into the definition of view factor, we arrive at the expression for the view factor between two differential black surfaces. This expression can be extended to all surfaces with diffuse emission, even if they are not black. Reciprocity. We have calculated the view factor of a differential surface 1 with another differential surface 2. Doing the same process for surface 2, the vision factor 2, 1, is obtained. If we multiply F1, 2 by A1 and F2, 1 by A2, we get the same expression. So we arrive at the simple reciprocity rule, whereby F1, 2 times A1 is equal to F2, 1 times A2. The view factor integral. The radiation leaving surface 1 and falling directly on surface 2 is obtained analogously to the differential surfaces. In this case, however, we must integrate over both surfaces. Finding the view factor in these cases is more complex and requires applying specific methods such as the Monte Carlo method or the crossed strings method. There are catalogs of view factors for standard configurations in which you can find formulas with which to calculate view factors between surfaces. In some catalogs, graphs are given instead of formulas. View factor relations or view factors algebra. The algebra of view factors is a set of rules that allow us to calculate view factors from already known factors in an enclosure. The first rule for calculating view factors is that the view factor of flat or convex surfaces with themselves is 0. For concave surfaces, each point on the surface sees other points on the same surface. Consequently, the view factor with itself is not 0. The next rule is that the sum of the view factors in the same row gives 1. That is, the sum of the view factors of the surface I with the rest of the surfaces of the enclosure and with itself is 1. This is for conservation of energy. The radiation that leaves a surface is distributed among the surfaces of a closed enclosure. As for the reciprocity, it is fulfilled both for differential surfaces and finite surfaces. And in a generalized way, for any pair of surfaces of an enclosure. With these rules, you should be able to fill in the view factor tables in the view factors exercises. Calculation example. For an enclosure formed by two cylinders of infinite length, the surface 1 is convex and the view factor 1, 1 is 0. And the view factor 1, 2 is 1. We apply reciprocity to find the factor 2, 1. And, finally, applying the summation rule, we find the vision factor 2, 2.